Okay, so I mean, if I'm not wrong, we were discussing about array
Yes,
matrices,
yes, yes. Matrices and determinants. Yes.
two-dimensional arrays. Uh, those are called matrices, and looked into how the process of why we can have such a structure, mathematical representation, coming from simultaneous equation as a simple example. We understood how the multiplication of the matrices works and the dimension of the matrices, what compatibility condition. So the left side matrix number of columns must be exactly equal to the right side matrix rows.
Number of rows.
Yeah, then only we can perform the multiplication, and also how the multiplication can be completed with the understanding of the relationship between the simultaneous equations with the matrix form equation, right? Okay, any questions or doubt about that? You're okay with that?
Yes, uncle. I'm okay with that.
Okay. Okay, I will open it. And then we looked into, can you see the whiteboard?
Yes, uncle.
Okay. Um, okay, it is sitting there. Okay, good. Yeah, I could see your mouse cursor is moving. Okay.
Yes.
And then determinant we started, and determinant on a square matrix will completely simplified with a kind of expansion, and we looked into a Laplacian expansion for 2 by 2 matrix, I mean determinant, and 3 by 3 determinants. And then we have seen how the -1 rise to the power of sum of the row numbers and the column numbers of that particular element multiplied by the element itself and multiplied with the minor of that particular element will get the, so we can either expand it on the row wise or a column wise, the results should be the same. So you are having any doubts or question about that?
No, uncle. No.
Yeah, okay, so you are quite confident. So in the school, they have started the matrices, the rest of the part they are teaching you or not yet?
Yes, uncle. We finished matrices and determinants. Now they are doing applications of derivatives. So
Okay, matrices and determinants. And do you have the inverse matrix and how to solve
yes, yes,
this
yes,
equation? So you have been taught with all those stuff.
yes, yes, uncle.
So you are okay with that? How to find the inverse of a matrix, square matrix?
Yes, uncle. Yeah.
So we don't need to look into that.
No, uncle.
Okay, you're completely okay with that, and you know how to cross check once you have an answer. And what methods are being taught for the inverse matrix? You have only one method, or even for the determinant, they taught you only the Laplacian expansion, or there is another method called the Gaussian.
No.
There is
We learned only the one, that one. That's it.
the same method what I told you, right?
Yes, yes, yes. That one only. Yeah.
So,
We do.
oh, okay, but is there application of the inverse matrix to solve the simultaneous equation? They taught you
Ah,
that.
yes, yes. That is there. That is there. Yes.
So Cramer's rule.
I don't know the name of the rule.
Okay, let's say I give you a simultaneous equation like 2x plus 3y equals some, let's say, 1, and 4x plus 5y equals -1. Let's say we have a simultaneous equation like that. So algebraically, you know how to solve them by cross multiplication of the coefficient and everything. That is completely normal algebra, right?
Yes, uncle.
And the linear algebra procedure is, first of all, we need to convert this into the matrix form that will look like 2, 3, 4, 5 multiplied by xy equals 1 minus 1. Makes sense to you?
Yes.
Okay, so that is how the relationship, and this is what I was mentioning in the beginning of our our session today, that multiplication of the matrix is actually the 2 multiplied with the x plus 3 multiplied with the y should be equated to the 1 on the other side. That will form the first equation.
Yes,
The
yes.
second equation. So that is how the basics of the all the things about the arrays form. Okay. So now we can write this. Okay. So first of all, you know this particular simultaneous equation, both these equations has to be completely two different equations. If they are scalable equations or something like that, then there is no, I mean, you cannot solve them explicitly. Makes sense to you?
Yes, uncle.
Okay, so in the matrix form, when we have it in the matrix form, how to check whether the equations, when in the matrix form we can complete and get a solution. Consider that this is our main matrix. Is that okay?
Oh, yes, uncle.
Okay, so then we can first check for find the determinant of this delta, the matrix. Okay, that will look like 2, 3, 4, 5. Is that okay?
Yes, uncle. Okay.
Then when you complete it, so can you tell me the expansion?
Yes, uncle. So it'll be 2 into 5 minus 4 into 3.
Okay, 10 minus 12.
10 minus 12 minus 2.
Minus 2 is the answer. So as long as this minus 2 is not equal to, this is not equal to 0, that means this property, this important property, delta matrix determinant not equal to 0 tells that this equation can be explicitly solved for explicitly explicitly solved for x and y. Do you get that?
Yes.
X and y. So once we establish that, so the one procedure of solving this is, okay, we can write this complete into a delta, and this x and y can be written as a, we'll call it as a, say A equals, other side is a B. Is that okay?
Yes.
So one thing is we could find the delta inverse. If you find the delta inverse, which is actually the matrix 2, 3, 4, 5, inverse of this, if we could do that, then all we need to do is delta inverse multiplied by delta, the A equals delta inverse multiplied by B. That will give the, so these two things will become an identity matrix.
Yes, sir.
And then multiplied by A will be equal to this delta inverse B. So first step will be to find the delta inverse. So you know how to find the delta inverse for this 2 by 2 matrix.
Yes, uncle. So when you find the adjoint first. So
yeah, okay. So already we found the determinant value is a minus 2.
Yes, uncle. So it will be adjoint of A by determinant of.
Let me write it straight away and see that whether you know this procedure. 1 over minus 2 and with the matrix of 5 minus 4 minus 3 minus 3 and 2. Okay?
Yes, uncle. Yes, uncle. Yeah.
Inverse. So take the minus 2 inside if you want, or we can keep it as such and get the job done later also, because this is just a scaling factor minus. Okay, I mean, we can get it inside also. So that will look like minus 5 over 2, yeah, 2 and 3 over 2 and yeah, minus 1. Is that right?
Yes.
Okay. So now we can also check this correctness of the delta inverse by this one. Like when you multiply with the delta, it should become identity matrix. Let's do that explicitly, okay, to make ourselves very much established. So what we are doing, we are trying to write this equation. Is that okay?
Yes.
So the equation explicitly, this can be written as minus 5 over 2, 3 over 2, minus 1 multiplied by our 2, 3, 4, 5 whole thing multiplied with xy equals, the inverse matrix is a minus 5 over 2, 2, 3 over 2, minus 1, whole thing multiplied with 1 and minus 1. Okay. Is that okay?
Yes, sir.
Now tell me the multiplication. So this will look like
5/2.
Why you take so much time? Minus 5 plus 6. You have to take this particular.
Okay. Yes.
Yeah,
Yes.
you're thinking
Yeah.
too much time. I don't know. I mean, it has to be fluent. You need to
Yes,
remember this, right?
Yes, sir.
The whole matrix, when we started, actually, you only brought that you made some mistake with matrices multiplication. You
Yes,
get
sir.
it? But
Yes.
once we understood how the matrix is formed from the simultaneous equation, and then the meaning of the matrices multiplication by checking the compatibility and everything, our back of the mind should always think about it and work about it and go fluently with all these procedures.
Uncle, it will be -5 plus 8, right?
And that means something somewhere wrong. Because I wrote it because I want a 1 sitting over there. You are right. 8 is right, but that means somewhere some mistake has happened. Do you get that?
Yes. Okay.
Because this should become identity matrix.
Yes.
Okay, where the mistake is. Determinant is okay. 10 minus 12 is minus 2. And when we get the inverse of this matrix, let us go here. Determinant 1 over determinant, that is 1 over minus 2 is correct. Inside the cofactor adjoint of each element, for the 2, we need to forget that row and the column, and the diagonally 5. And the power is 1 plus 1 is 2 minus 1 power 2. Positive 5 is right.
Yes, sir.
For the 3, okay, forget about the first row, second column, 4, and then the power is
-4, correct only.
minus 4 is correct, and then minus 3 is also right, and 2 is also right, isn't it?
Yes, uncle.
And then take the minus 2 to divide inside, it will be minus 5 over 2 plus 2, 3 over 2, everything looks correct. Oh. Do you find any mistake?
No.
Then why the multiplication is not giving us an identity matrix? Minus 5 plus 8 will give you a 3. That is not right. Inverse matrix, we need to find the determinant, divide by determinant, and then write each element's joint, and that will be sign. Okay. What is happening to me? Second. Let me check the. Do you keep looking into the calculation and check where the mistake has happened? Okay. So 2, 3, 4, 5. Want to find the no.
Not sure. Not sure the mistake.
Yeah, 1 second. Minus 5 by 2. 1 second. Okay. I know what that means. When the okay, this is where the mistake has happened. When the power is even, then we need to, because this is the 3 and 4 stay like 3 and 4. We should not change that. What is the reason for that? Because the inverse matrix is minus 5 by 2, 3 by 2, 2 minus
Okay.
3 by 2, 2 minus 1. No. 1 second. Minus 3 by, yeah, minus 3 by 2 and 2. Yeah, that is what it is. 2. Okay, this stays as 3 by 2 and this stays as a 2.
Yes.
Then where I am making the mistake? In the procedure, I mean. Okay, 1 second. Let me share the document which has the procedure. Okay.
Yes, sir.
And then we will see that what is the mistake we have done with the procedure, main procedure itself. You see, we have done something, and I explicitly did the inverse matrix multiplied by the main matrix to see that I want to get the identity matrix. And in doing so, we found that we made mistake. We get that. Do you understand what I'm saying?
Yes, sir. Yes, sir. Yeah.
That is very important, because we would have just thought that the inverse matrix is correct and completed the other side of the multiplication and given an answer for x and y. But we need to be very careful, and we need to be, whatever we are doing, it has to be checked in all possible ways whether that is right or wrong. Do you get that?
Yes, uncle.
This mistake will make us to learn about the inverse matrix in a much better, correct way. Is that okay?
Yes, sir.
And matrices, where is the matrices? Inverse of a matrix. Okay, let me get the document. Okay, let me share the document to you so that we can look into. Okay, continue. How to. Okay, let me go to the next page. Because if I share, then it is actually killing this page. I don't want that. Okay. So let me take that particular line out to adjoint goodness of the 2 by 2 matrix. Okay, here. I'm taking a snapshot of the inverse of the matrix procedure, and I will bring that here. Okay. Okay, can you see this?
No, uncle. I can only see the whiteboard.
It may take a few minutes. Can you see now? Are you on the second page? Okay, you have to move to the second page. Sorry.
Oh, okay.
Because I'm using a different, the whiteboard in the Zoom itself.
Oh,
Can you?
yes.
Can you see that? Yeah, okay.
I can see page 2. Yeah.
And you can see the...
Yes.
Okay. So the inverse matrix of 2 by 2 is the determinant has to be non-zero. And if the matrix has to be A, B, C, D, then inverse is 1 over the determinant, and D, yeah, D and A is swapped,
Okay.
and B and C will get only the sign change.
Yes, sir.
Okay, this is the procedure for the 3 by 3. I mean 2 by 2. Let me
Yes.
check the 3 by 3 to get the general idea why that is happening, everything. That will make us inverse Gaussian elimination method. That's okay. Okay. Determinant method is adjoint. So still, so we get the adjoint is okay, and then attach the sign. That is called the minor. So the solution would be okay, 1 over determinant of the matrix, adjoint of the A. Okay, in doing the adjoint, how to get the adjoint? So adjoint is 3 minus 1, 2, like that. What is the problem here? Okay, let me get the snapshot of the procedure for the 3 by 3. Okay, quickly I will get you that. Because I want to understand the 3 by 3 procedure and apply that for the 2 by 2 also, it should be okay, right? That is what I was thinking. I did that.
Yes, sir.
Okay. Transpose is we have forgot the transpose step.
Oh, transpose will be negative.
That step is missed.
Yeah. Okay. Yes, sir.
Okay.
Yes.
Yeah, okay, now I got it. Okay, we okay, let's do that here in this page. Okay. Okay, let me try to do that again correctly. So our delta is, okay, let me write it here. Can you see that my writing on the second page?
Yes.
Delta inverse is, we want the inverse of 2, 3, 4, 5, right? Right.
Yes, uncle. Yeah.
And we have already calculated the, okay, my system is eating away. That means my system gets slowed down with PowerPoint, with this. Because my system makes many sound, much sound means need to get the, otherwise my writing get disturbed.
Oh.
What I have to do? I have to close some of my applications, then only I can get back. By the time, can you work out the adjoint
Yes.
correctly with a paper and pen?
2, 3, 4, 5 into.
Try that again. So the determinant is minus 2. We calculated that correctly. And the adjoint of delta. This is our
5.
okay, what is the meaning of adjoint itself? Adjoint is before the transposing. No. What nonsense is this?
Yes.
Adjoint itself is after transposing only is called the adjoint, right?
Yes, Uncle. Before that, it's called the cofactor in this table.
Okay.
Cofactor will be 5 minus 4 minus 3
So
and 2.
okay, so we first go for cofactor. Cofactor of delta, that will look like our 5 minus 3, right?
Yes, sir.
No, not 5. It's a 2. No, 5. Yeah, 5 is correct. 5 minus 4, right?
Yeah.
Minus 4 minus 3 and our 2, isn't it?
Yes.
And the adjacent will be transpose of the cofactor. That will look like 5 minus 3 minus 4, 2. Am I right?
Yes, sir.
And then the inverse itself will look like 1 over minus 2, 1 over minus 2, the adjoint of the delta, minus 3 and minus 4 and 2. Is it okay? Okay, now we can write that delta inverse as, take the minus 2 inside, that should get us the right one. Minus 5 over 2.
Minus 5 by 2 is 6.
Positive 3 over 2. Why 6 is
Okay,
coming?
yeah. Not 6, sorry. 3 by 2 and 1 by 2 minus 1.
2 and a minus 1. Why 1 by 2? See my writing?
Okay, right. Yes, uncle. Yes, uncle.
Okay, so double check that whether we have done it correctly. So minus 5 over 2 and 3 over 2. Okay, so 2 and then minus 1. Multiply this with the original delta matrix. That will be 2, 3, 4, 5. Right. This should give us the identity matrix. That means we found the inverse matrix correctly. Okay, so this will be minus 5 plus yeah, plus 6 is correct. Yeah, plus 6. Are you following?
Yes, uncle.
Okay, and this one
So
will minus 15 by
15 by
2,
2
and
plus 15 by 2
yeah,
only.
is coming. Yeah, that's good.
4 minus 4.
This is 4 minus 4. Good. 0 is appearing. The final element.
And 4 minus 5.
4. Yeah, 4 minus. No. 4. No, 6. What you are doing? 6 minus 5. You are not doing the multiplication. Again, you are making mistake.
Yeah, okay. Yeah, 6 minus 5. 1. Yes.
Okay, you have to find a way to look through because there are elements all over the place. All of them are numbers.
Yes.
Okay, they will mess you up. Do you get that?
Yes, uncle.
I now can I understand why you are making the mistake in the matrix multiplication. You are not looking through that. Okay, when I do this job, you can even use a pencil or something to write it and get it very clearly. This has to be done to get this element. Do you get that?
Yes, uncle.
And again, when you do this with this, that will get you this element. That has to be very clearly seen through by your thought process. Is that okay?
Yes, uncle.
This one with this one will fetch you this guy. And again, this one with this one again will give you this. That has to be perfectly done. So we got this one as a I. Do you get that?
Yes.
It's called the identity matrix of 2 by 2 dimensions. So I2 is called I2. Okay. Okay, once we got that, we can do the multiplication of the other side also. So what I do, I will try to kill some of my application to see through that whether I could get my computer back. Okay, because I hate this. Force grid. I will see what are all the things I can kill. I don't have too many of them. Why it is eating away the... Okay, let's kill the... I will kill few of my application and see whether I can recover. Still the sound is coming. I killed almost everything, but still the sound is coming. This is not good. What is eating my... Okay, what I do, I will restart my computer. Okay.
Okay, yes.
Okay, you please be online. I will be...
Yes, yes.
But the recording will all get disturbed. I don't know why this is doing like this. Because if I go away, all this thing will get completely... What I do, let me change UB.
Maybe you can save this PDF and send it, I guess, so that it won't get...
Yeah, but the recording, I want to keep it as a one single... I don't know which is eating so much of my process. You could hear that noise, background noise.
I can't hear it.
There is a constant noise that is always there. Okay, my mail also, I will quit the mail. It's like bit of the sound has gone down. Okay. Okay, let's continue. Yeah, my sound has bit gone down. Let's continue and see whether that is helping us. Is that okay?
Yes.
Okay, add to the next page. So I would... Okay, can I go to the third page?
Yes, sir.
Okay, so this is what we have done. So we have the original matrix was 2, 3, 4, 5 and multiplied with xy equals 1 and minus 1, right? You remember that?
Yes, sir.
Okay, now we got the inverse matrix. Just write it again. That will be minus 5 over 2. And here it is a... what was that? You remember the... Okay, quickly I will go to the... Quickly go to the previous page. Minus 3 by 2, 2, minus 1, minus 3 by 2, 2, 1. Right.
1. Yeah.
Okay, I will double check and then 2 minus 1.
Yeah, y minus 1. Yes.
A minus 1. Here it should be a minus 1. So with this, when you multiply, the pre-multiply with both the sides, 2, 3, 4, 5. Okay. And this is the 3 elements. Okay. I mean three matrices, one after the other.
Yes.
You get that? So this side also, it will be minus 5 over 2, minus 3 over 2. Still got that noise and allow me to 2 minus 1 whole thing multiplied with 1 minus 1. They're okay.
Yes.
Okay, so this one we already checked it. This gave us 1, 0, 0, 1.
Yeah.
Multiplied with xy.
Xy
Equals, this side we need to get the multiplication done.
So it'll be minus
like
5
this
by
one goes with this one. Do you get that?
Yes, uncle.
Yeah.
Minus 5 by 2 plus 3 by 2
plus 3 by 2, 3 over 2, and 2.
and then it will be
2.
yeah 2 plus
1. Okay, so this leads to xy. So this multiplication also, if you multiply this with this, you get only x. Do you get that?
Yes, yes.
And if you multiply this with this, you will get only y. That is why.
And that's why it's like I into anything will be that a.
Resultant one. Okay. So x and y is explicitly solved as other side values are
minus 1 and 3.
2 and 2 and half minus 1 and half will be a minus 1. Is that okay?
Yes. Minus 1 and then 3.
3.
So x will be equal to minus 1. Y
is that right? Plug it back into the original equation. 2 into minus 1 plus 3 into 3 is actually equal to, no, where the mistake is. I made a mistake somewhere. No, this is
2x plus 3y is 1. Okay. Yeah, it's correct, right?
No. Original no, the 1 and minus 1 is not right. I think so. Wait a second. I will check.
The original equation is 2x plus 3y is equal to 1.
4x plus 5y equal to minus 1. That is what I started. But actually, I thought I am okay. Then why the answer is not coming correctly?
All right.
So it's a minus 5 by 2, minus 3 by 2, 2 minus 1. Let me double check the inverse matrix. Minus minus. No, minus. These two are minus and that is a plus. Why I am doing? Inverse matrix is wrongly written. This is a plus. Okay. This is a plus.
Oh, right. Okay. So that will be then minus.
Yeah. So minus, this is also a minus.
Yeah.
Okay. So that is 2.5 plus
minus
3.5 is a 5, right? No. 2, 3, 4, right?
4.
This answer is a 4. And then this is a 3. Okay. So now check it. 4.
Minus 4.
Oh, minus 4. Right. Minus 4. So minus 4 here. So that will give you minus 8.
9 minus 1. Yes. Yes.
Yeah. Minus 8 plus 9 is going to be our 1. Right.
Yes. Yes.
Yes. Similarly, if you go for the second equation, 4 multiplied by minus 4 will be minus 16. Right. And
yes.
Then plus 15. Yeah. Okay.
Yeah.
That is a minus 1. So you see, we should have all the possible ways to check our steps and the procedure whenever we are there itself, because we should not carry over the mistake until the end and then go back and try to find because that will completely waste our time. Do you get that?
Yes, sir.
We made a lot of mistakes today. Even the inverse matrix, we did
Yeah.
not do the transpose. So that we need to remember. Okay.
Yes, yes, sir.
And then when we wrote it from one page to the other, we missed the sign of one of the
Yeah.
elements in the inverse matrix. That actually lead to wrong answer. That also we checked and we corrected. So the main mistake was that transpose we forgot. That we need to remember. Okay, after finding
Yes, sir.
the whatever the cofactor. Okay. Okay, any questions?
No.
Okay, let me quickly show you what is uh the uh the other. Can you go to the next page, please?
Yes.
Okay, so we have this 2, 3, 4, 5. 4, 5 multiplied with xy. I will write the Cramer's rule, see whether that is included in your syllabus. Okay. There is a 1 minus 1. So what we did, first thing is we called the delta matrix, which is our 2, 3, 4, 5. Okay.
Yes, sir.
Main matrix. And we found the determinant also. That is determinant of delta is our
Determinant of delta will be 10
Yeah.
minus 12, which is minus 2.
minus 2. And there is, okay, when you are solving, there is a delta x matrix, which will be, you see this particular column belongs to our x, 2 and 4. Do you get that? We have to replace that with the other side element. Do you catch what I'm saying? So from the main matrix delta, the 2 and 4, the first column belongs to the x. Do you get
Yes,
that?
sir. Yeah.
And the x, when you write the delta x matrix, that x column should be replaced by the other side, right hand side column. Do you get
No,
that?
uncle, we have not done this.
Okay, let me finish this. It's not very difficult. Okay.
Yeah, okay.
Because you may have handily this method also, because matrices 2 by 2 kind of problem, this is much easier. Do you get that? So find the delta x determinant. What is the answer for this? It will be a 5 plus 3, 8. You're okay with that?
Yes, sir.
Okay, can you tell me what is the delta y determinant?
Okay, so delta y.
Matrix itself, yeah.
Yeah, okay. Matrix. So
2, 4 is a x1. They won't change. Do you get that?
okay.
The y
And then 1
column
and
should
minus
be
1 will
replaced.
be
Yeah, 1 and minus 1 should be. That's it.
okay.
Okay. So what is the determinant of
So
the?
it will be minus 2 minus 4.
Yeah, so that will be
Yeah.
minus 2
Minus
minus 4 will be a minus 6. Is that
minus
okay?
6. Yes, sir.
So once we found all these, x is calculated by simply the delta x determinant divided by delta itself. Okay.
Yes, sir.
Of delta. So this will become our minus 8 over minus 2, that will be minus 4.
Minus 4. Yes, sir.
Minus 4. Y is calculated as delta y divided by delta. Okay. You are following this procedure. It's not
Yes, sir.
one. It's called the Cramer's rule. Okay. The
Okay.
mathematician called Cramer.
So it will be minus 6 by minus 2, which is 3.
Yeah, you get the same answer like the previous method. The inverse method.
Oh, okay.
Okay with that.
But this is more simpler, like
Yeah,
shorter.
for 2 by 2, it will be easier, and 3 by 3 also easier. But if you go more than 3 by 3, let's say 4 by 4, the inverse may be a better way.
Okay, yes, sir.
But any of this method, inverse method or this Cramer, okay, I will write that as a Cramer's. Okay, this is the mathematician name.
Okay.
This is called Cramer's rule. Still, my computer is not allowing me to write fluently. Okay. So let me go to the next page. Have you been taught with the Gaussian elimination method to find even the inverse?
I'm not sure of the name, uncle. I
Okay,
don't.
okay. Let me do that. Okay, let's do the 2, 3, 4, 5 is the matrix. We want to find the inverse of that, right?
Yes, uncle.
So what we do in the Gaussian elimination method, we write the equivalent identity matrix parallel to this. Do you see that?
Yes, uncle. Okay.
And hope you learned the row operations and the scaling operations in our determinant. You know that? You learned that?
Like,
Okay,
no.
I will tell you what I am doing. Okay.
Yeah, okay. Yes, uncle.
I am going to get a job done. I will write what is the job I am doing. So the whole procedure is completely the objective of the procedure is do the row operations in the 2, 3, 4, 5. So we want to convert this side to be look like 1001.
Okay.
So I will show you what that procedure is, the row procedure.
Yeah.
The row procedure is you do that so that this should convert to the 2 should become a 1, 3 should become a 0, 4 should become a 0, 5 should become a 1. Do you get that?
Yes,
We
uncle.
are going to do that using the row operations. The row operation is very simple. How to make the 2 to become a 1? You simply divide the first row by 2. Is that okay?
Yes,
So I'm
uncle.
going to write it as there is a new row 1 which is given by the row 1, the old row 1 divided by 2. Is that okay?
Okay.
So that
Okay.
means we have to do the complete division of the whole row. That means 1, 3 by 2 and put the vertical line. Other side will be 1 over 2, 0. Is that okay?
Yes, uncle.
Okay. But the other one will wait. Okay. We are not doing anything with this. Okay. Is that okay?
Yes, uncle.
Okay, once done, then when we make, okay, the procedure is whatever the size of the matrix, start with the very first row, first column, make the element 1, then use this to make this guy 0. Do you get that? I will write the procedure and then you can understand what I mean. I mean, there is a new row 2. This is nothing but the old row 2 minus 4 times the row 1. Makes sense to you?
Okay, yes, uncle.
Because you see the 4 number in the row 2 element, we want that to become a 0. So use the row 1 element 1 value, multiply that by 4. So 4 minus 4 will become a 0. You're okay with that?
Yes, uncle.
Okay. So here we are changing the row 2. So the row 1 will not be affected. So 1, 3 by 2 and 1 over 2, 0 will wait. Nothing
Is this called elementary row operation or something?
Yeah, it's called the elementary row operation,
Yeah,
but
no, this was deleted in the textbook, so they
okay,
that's why I don't.
but it is not confusing you, right?
No.
You see the target what we are doing, right?
Yes, yes, sir.
So now tell me the second row after this operation. The new row 2 should be calculated by the old row 2 minus 4 times the element corresponding element in the row 1. So what will be the first element?
So row 2 means it'll be so 4.
4
No, sorry.
minus 4 times 1. That will be a 0. That is
4. Okay, fine.
target.
4.
This is our target. You get that?
Okay, yes, sir.
Okay, and then 5 minus 4 times 3 by 2. Do you understand that?
Okay. Okay,
That
fine.
is the corresponding element. So 5 minus 4 times 3 by 2 is going to be a 6. So 5 minus 6 will be a minus 1.
Minus 1.
Okay, do the same thing in the 0. 0 minus 4 times row 1. How much it will be?
0 minus 4 by minus 2.
Minus 2. Minus 2. And then the last one. 1
So
minus 0 will be 1. You're okay with that?
Yes, sir.
So we now achieved completely the first column. Then go to the second column. Our target is to convert this as a 1. Do you see that? That is the first job. Do you get that?
Yes, sir.
Because that is the idea. So this has to be converted to looking like 1001. Makes sense to you?
Yes, sir.
So I'm going to write here. Okay, I will cancel these arrows. I will write a new operation. This operation will be whatever the last one we have. Our row 2 has to be how to convert the -1 to a +1.
Multiply with -1.
We can do that. So that will be -1 times our row 2 itself. You get that? The old row 2.
Yes, sir.
Okay. So if you do that, let's write this. So because of this operation, the first row will get unaffected. Is that okay?
Yes, sir.
Okay. Of and a 0. And this is a 0, 1. And that -2 will become a 2. And +1 will become a -1. Are you with me?
Yes, sir.
Now, the last step is this 3 by 2 should become a 0. So to do that, make use of this 1. Do you get that?
Okay.
Okay. So that will be, this is a procedure on the first row. So we are saying row 1, the new row 1 is actually whatever the current one minus 2 by 3 row 2. Makes sense to you?
Okay.
Row 2. So that will make this one will be unaffected. 0, 1.
Yeah.
And this side 2 minus 1 will wait as such. But in this, the 1 minus 2 by 3 or 2 will not affect the 1. Do you get that? Because we made this as a 0. Do you see that? That is why this way of procedure will unaffected the 1. Do you see that?
Yes, sir.
And 3 by 2 minus 2 by 3 of, no, we want this to be 0, right? I told something, you are also saying, okay, this should be 3 by 2 itself.
Okay. Okay. So 3 by 2 of,
yeah, because 3 by 2 minus 1 times 3 by 2 will be 3 by 2 minus 3 by 2 will be a 0.
Okay.
You get that?
Yes, sir. Okay.
And here there is a of minus twice 3 by 2, that is of minus 3. That will be
minus 5 by
minus 5 by 2. Yeah,
Minus
5 by 2.
Yeah.
2.5, right? Okay. And then finally, 0 is the current one. Minus 1 multiplied minus 3 by 2 will be a
3 by 2.
3 by 2. Okay, this is the inverse matrix. We got the inverse matrix.
Okay.
So this is our delta inverse.
Okay. Yes.
This is the very efficient method and procedure, because the row operations is by the value of the numbers we will be doing that. And if you go to the bigger dimension matrices, this procedure will be much easier.
Okay.
Do you catch that?
Yes, sir.
So in the computer programming also, if you want to write a code algorithm to make this inverse matrix, this procedure will be much easier. Do you get that? Algorithm wise, this step is the better method.
Okay.
Okay. And also
Yes.
this procedure can be used directly for solving our the original problem itself. I will show you that. What is the original problem? 2x plus 3y equals 1. This is called Euclidean row operation. It's also a Gaussian elimination method. So this is a 4x. My writing is always getting really messed up. The computer is giving me headache. Okay, equals -1, right?
Yes.
Okay. So
Okay.
what this procedure is, this is something like we write the, okay, you write the Euclidean matrix like this. This is converted into 2, 3, 4, 5, and put a vertical line and put the 1 and -1 here. Is that okay?
Yes.
Okay. So the
Okay.
target is convert this into 1001.
0, 1. Okay.
That will straight away give you the answer for the X and Y here.
Hmm.
Can we try this?
Okay.
So what will be the first step? First row operation is?
Yeah, the first 2 should be converted to 1.
Okay.
Right.
So the R1 becomes, R1 is actually given by, okay, let me write it. R1 divided by 2 is actually our new R1. Is okay.
Okay.
Okay, I write it this way. Okay, so that will be 1, 3 by 2. And put the vertical line. This will be 1 by 2. Is that okay?
Yes.
And 4, 5 will wait. Okay, we are not
Yeah.
doing anything with the
4, 5 minus 1.
5 and -1 will wait. What is the next thing? Next step is, what is the target? To make the, use the 1 we achieved.
Yeah.
So in
Get
that,
4.
yeah, make the 4 0. Do you get that?
Yes.
But let's say it's a 3 by 3 problem. First to get the 4 become a 0 and use the 1 again with the third row also to make it 0. Do you get that? You understand what I'm saying?
Yes, sir. Yes, sir.
Okay, so we need to complete the first column. Make the very first element, as it is a first column, make the very first element in the first column to make it 1, and then use that 1 to make all the other elements in the first column to be 0. So to do that,
Okay.
it is a row 2 minus 4 times row 1.
Okay.
Okay. So that is going to be our, this is the new value for our row 2. Is that okay?
Okay. Yes, sir.
Okay. No, 4 times row 1. This is a row 1. Okay, this is our new row 2. So the 1, 3 by 2 and half will wait. Is that okay?
Okay. Yes, sir.
And this 4, now 4 times, 4 minus 4 times 1 is a 0. Calculate this one. 5 minus
5 minus 15. 1 second.
It will be a -1.
1 second.
Right? Why you take so much time? 5 minus 4 times 3 by 2. 4 times 3 by 2 is here. 2 times.
Okay, it will be -1.
5 minus 6 is -1. But it's not that you need to write straight away. You can write that as a 5 minus
Yes,
4
sir.
times 3 by 2 as a 1 extra step and do that, because I'm doing it because I feel that I'm confident to do this. But as you are quite young, you can avoid the mistake by writing it. And what happened will be the -1. -1 minus of 4 times half. So that
-1 minus of 4 times 1 by 2. So it will be -3.
Okay, good. Okay, now what is the next step? To make the
that should be 1. -1 should be 1.
Yeah, good. So that will be our, I put the arrow mark. So we know that row 2 divided by -1 or multiplied with -1 will be our new row 1. Is that okay? New row 2. So this is our, should be transformed as a row 2. So just a -1 multiplication. So this will look like our 1.
1, 3 by 2 will remain.
Yeah, and also other side also the half will remain. Half is also.
Yeah, half will remain. So it will be 0, 1 and 3.
0, 1 and 3.
Yeah.
Okay, and then we got the 1
by 2 should become 0.
0. Use that 1 in that column. Okay, so that will be I write it as the row 1 minus 3 by 2 row 2. Is that okay?
Yes.
Row 2 should be our new row 1. New row 1. Okay, so that will be the row 2 will be unaffected. You get that? Okay, so the 1 will
Yes.
be 1 minus 3 by 2 times 0 will be a 1. 3 by
1,
2 minus 3 by 2 times 1 will be a
0.
0. Of minus 3 times 3 by
3
2
by
will be a 9 by 2
9 by 2. So minus 8 by 2. So minus 4.
minus 4. That's it. We got the answer for the x and y. You get that?
Okay.
So this tells us, so this tells x is nothing but minus 4 and y is a 3. You see, this procedure is, you don't need to find the inverse matrix and then multiply all these things, is completely straight away done it with one row operations of the complete Euclidean. This is called Euclidean form. ON. Okay, Euclidean. ON form. The original one I have written. We get that.
Yes.
This one is called the Euclidean. Euclidean. Okay. Yeah. Any questions?
No.
So if it is a 3 by 3, I hope you can understand what I mean.
Yes.
Let me consolidate by writing that procedure to you so that you will understand what I mean by that. So let's say if you have a A, B, C, D, E, F, G, H, I. For example, elements are like this.
I actually have another class right now. Like,
Okay. Think about it, how to convert this into identity matrix.
yes,
By
yes.
procedure. Okay. Okay then.
Okay.
Okay.
Thank you.
See you next week. Okay. Bye.